Hello everyone. This lecture is about the number system. So the basic number system that we are going to discuss in this lecture was decimal, binary, octal, hexadecimal and radix pi. We need to look for the table or how we can make the table for this 5 number system where the decimal is going to be reference, where remaining is going to be with respect to the decimal we are going to convert this another 4 number system. So the general formation for writing the number system, which is defined like that, it's having the integer part as well as it's having the fractional part. Both is going to be defined with the power of starting from b raised to 0, b raised to 1, b raised to 2, b raised to 3, as so on. As well as for the fractional number, it is going to be multiplied with the a minus 1 with the b raised to minus 1 with b raised to minus 2, b raised to minus 3, b raised to minus 4 with respect to that particular number that we have given. Okay, so that is the general information for the number system. Now how we can write the binary number system, where in the binary, which is generally known as a radix 2, but its famous name was the binary. So here we are having the reference number like 0, 1, 2, 3, so on up to the 21. So how we can write down in the binary? So binary only having the 2 digit we have 0 and 1, because the 2 number is only going to be allowed as it have the radix 2. So the 2 number we have 0 and 1. So what happened after that 0 and 1 is complete? We need to increase that 1 number just left after that and again repeat the sequence that is going to be previously that we have mentioned in the 0 and 1. So here 1 is going to be added and sequence is going to be repeated as a 0, and again the next number is going to be 1. So our next number for the 2 and 3 was 1 0 1 1. Now again that 1 1 is going to be finished. What we supposed to do for the next number? Again we need to add the number 1 in the left hand side, and again we need to start this sequence previously that we have seen just above the 2. So we can say the previous sequence we have possibilities we have that 0 1, again this 1 is going to be finished, so again we need to add the 1 number over here, so it's going to be repeated as a 1 0 1 1, and 1 is going to be continuously written as it is. So we can say our final number at the 7 1 1 1. Now what happened after the 1 1 1? Just we need to add the 1 number in the left hand side, and again we need to start with the 0 0 0. So after that 0 0 0 we are having the plus 1, it means we can say 1 over here. After that 1, again we need to add the 1 digit over here and start the sequence from the 0 in the right hand side. So 1 over here, sequence is 0, next 0, then 1 1. After that, if this 1 1 is going to be finished, again 1 number is going to be added over here and remaining digit is start with the 0 0. So likewise we need to move forward from the 0 1 0 1, then 1 0 1 1 1 0 0 1 0, and likewise we need to write down that number from decimal equivalent to the binary. So over here that after the maximum number 15, again it's going to be added with the 1 and remaining number is starting with the all 4 0. So this number is going to be now there is one question over here, that when we are having the number 15, so the number maximum equivalent binary was 4 times 1. When we are starting with the 16, so 1 is going to be added over here, so remaining 4 bit is again going to be repeated from 0 0 0 to 1 1 1. So we can say after that again sequence is going to be finished and we need to again start with the 1. So that is type of the conversion procedure we have in the radix 2 or binary. What about the octal? Now in the octal we are having the maximum number is going to be 7 and minimum number is going to be 0. So 0 to 7 we are having the total 8 number we have that we can apply over here. So over here decimal equivalent octal we supposed to write down here. That decimal we have 0 1 2 3 4 5 6 7 8 up to the 21, where octal we have 0 1 2 3 4 5 6 and 7. Now maximum number is allowed in the octal is 7. So what is the next number octal equivalent to the 8? The same thing that we have applied in the binary, something that same type of the analogy we need to apply over here. we need to add 1 in the left hand side, and we need to repeat the sequence that we have done previously. So sequence is going to be repeated like 1 is going to be added, then 0, then 1, then 2, then 3, 4, 5, 6, 7, like that. So up to the 7, this 1 is going to be as it is, but after that this right hand side sequence is going to be finished. So what we supposed to do? We need to again add the number in our left hand side, and again we need to start the sequence from 0. So that number is going to be increased by 1. So 1 is going to be replaced with the 2, and sequence is again going to be start from 0, 1, 2, 3, 4, 5, and so on. Now this number is left hand side number is maximum going to be up to the 7. Now after the 7, what we have? Again we need to jump for the next bit, then we can start with the number conversion with the 3 bit. Okay, so that is the simple procedure for the convert from decimal to octal. Now what is the hexadecimal? Now in hexadecimal, generally known as a hex number, where the radix 16. So our maximum range is from 0 to 15 number, but 15 is going to be conflict with the decimal number. So over here, that equivalent to the 15 is we can represent as a F. So we can say after the 9, whatever the number instead of 10, we are going to be represent as A. So A, B, C, D, like that, it's going to be vary up to the A to F for the 10 to 15 number. That is going to be calculated in the hexadecimal. So let's see in the table. Now the equivalent decimal number 21 we have taken. So it hex start with the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now 10 equivalent we have given the number A. Similarly, starting with the A, so B, C, D, E, F. So 15 number is going to be ended over here as per the radix 16. So we can say maximum 16 number we can represent with the 0 to F. Now F is going to be that sequence is finished over here. So what we can do for the next number? Same as the previous case, we need to add in the left hand side 1, and we need to repeat that sequence from the beginning. So 1 0, 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, so on and so forth. Okay, so that is the number system conversion from the decimal to the hexadecimal is represented over here. Now let's consider that some miscellaneous type of the number system. Let's take the radix 5. Now in radix 5 we have the knowledge like that radix 5 having the base 5, so maximum number allowed was 5. So we can say the maximum number contained in the radix 5 was 0, 1, 2, 3, 4. That's it. So that 5 number is going to be represented in your radix 5 type of the number system. So how we can work with that? So equivalent to the decimal, let's start with the 0. So 0, 1, 2, 3 and 4. Now we need to stop over here. So for the next number 5 is going to be represented over here as a similar as the previous case. We need to add the 1 number in the left hand side, and we need to start the converting from the beginning. So like 1 0, 1 1, 1 2, 1 3, 1 4. Now this 4 is going to be finished over here. So we can say again we need to add the 1 number in the left hand side. So it's become the 2, and sequence is again going to be start with the 0. So 2 1, 2 2, 2 3, 2 4. Now 4 is going to be ended over here. Again we need to add the 1 number in the left hand side. So 2 is going to be increased with the 3, and the sequence is again going to be repeated from the 0. So 3 0, 3 1, 3 2, 3 3, 3 4. Now 4 is going to be ended over here. So again we need to add the 1 bit left. So 3 become the 4 over here, and we need to start the sequence from the beginning. So that is about the radix 5 equivalent to the decimal. Now that is just the comparison table for the 16 number that we have discussed up till now: decimal, binary, octal, hexadecimal, and radix 5. So equivalent to the decimal, now you are able to write down that it's 0 1, then 1 0, 1 1, 1 0 0, 1 0 1. Likewise that we have done in the previous case. Now in the octal, we can say that the equivalent to the decimal, we can go up to the 0 to 7. But after that 7, we need to start with the 1 0, 1 1, 1 2, 1 3, 1 4 up to the 1 7. And again we need to start the increase left hand side bit, and we need to start with the 2 0, 2 1, 2 4, so on and so forth. In the hexadecimal, what we can do, we need to go up to 0 to 9 first, and after that equivalent to the 10 we will give the A, B, C, D, E, F. Now at the F, equivalent to number 15 is ended, and our hexadecimal sequence is also ended, so we need to add the 1 bit left hand side, and we need to start with the 1 0 1 1 1 2 1 3 up to the 1F for the next numbers. Now what happened in the radix 5, just we have seen in the previous slide that a maximum number is allowed over here is 4. So it's starting with the 0 1 2 3 4. Adding the bit into the left hand side, sequence is again going to be started with the 1 0 1 1 1 2 1 3 1 4. Again add the bit in the left hand side, started with the 2 0 2 1 2 2 2 3 2 4, and after that it's going to be added with the 1 bit more, start with the 3 0 3 1 3 2 3 4, so on and so forth. Okay, so that is all about the number system we have. So we have discussed the decimal, binary, octal, hexadecimal, radix 5, or any type of the radix you can convert by using this analogy. Thank you.